Hello students, good morning. Today we will see the next point. It is the phase lock loop. It is the PLL. PLL, it is the phase lock loop. Okay. The figure which is shows the block diagram of PLL. PLL which is stands for phase lock loop. Okay. So see the first block in this block diagram, it is the phase detector. This phase detector, it has two inputs. First one, it is the input signal frequency with frequency Fs and amplitude Vs. Okay, and output of VCO at frequency FO. Phase detector, which is act as a comparator which compares two signal and produces the error voltage. This phase detector which has two input. First one, it is the input signal at frequency Fs and amplitude Vs, and another input from the VCO, and this VCO which it generates the frequency of FO. These two inputs are given to the phase detector. By using these two signal, this phase detector which it generates the error voltage, this error voltage which is the VE. VE, it is the error voltage. The error voltage is depends on a phase difference between the Fs and FO. The error voltage is depends on a phase difference between the Fs and FO, and the output, that is the error voltage, which is given to the low pass filter. Okay, the low pass filter passes low frequency signal and attenuates the high frequency signal. Low pass filter passes low frequency signal and attenuates the high frequency signal. The output of low pass filter is given to the amplifier. Output of low pass filter is given to the amplifier. Low pass filter which passes low frequency signal and attenuates high frequency signal. The output of low pass filter, it is given to the amplifier. Next one, it is the amplifier. It is used to amplify the filtered signal and amplified signal which is denoted by VC. It is used for the amplification purpose, and amplified signal which is denoted by VC. VC which is called as a control voltage. VC which is called as a control voltage. This output which is again given to the VCO. Okay. This VCO which stands for voltage control oscillator, whose output frequency varies accordingly the control voltage VC. VCO which stands for voltage control oscillator, whose output frequency, that is the FO, which is varies accordance with control voltage VC. FO which is varies accordance with VC. There are three stages of VCOs. First one, it is the free running, next one it is the capture, and last one it is the phase lock. In free running, there is a no control on a FO. In a free running stage, there is a no control on a FO. Next one, it is the capture. In this capture mode, the comparison of FO and FS which is starts or begins. Okay, the comparison of FO and Fs which is starts or begins. And last one, it is the phase lock. When your FO which is exactly equal to the Fs, then PLL which is said to be phase lock. Okay, when your FO which is exactly equal to Fs, then PLL is said to phase lock. Okay, so this is the PLL, that is the phase lock loop. This PLL which is used for the FM demodulation. PLL which is used for the FM demodulation. So we will see PLL as FM demodulator. PLL as FM demodulator. Okay. In the PLL you have to add only one capacitor and write all the explanation of PLA and only write the output Vc, it is given to the capacitor. The output Vc which is given to the capacitor. Capacitor function is the capacitor which is blocks DC signal and passes only AC signal. Capacitor which blocks DC and passes only AC signal. So at the output we are getting the original signal back. So at the output we are getting the original signal back. The capacitor which blocks the DC and passes the AC signal. So at the output we are getting the original signal back. So this PLL which is act as a FM demodulator. What is the demodulation? In this demodulation process we are removing the carrier signal and recovering the original signal. So at the input FM signal which is given and see the output, at the output we are getting the sine wave, that is the original signal back. So this is the PLL as FM demodulator. So see one example. A super heterodyne radio receiver with an intermediate frequency of 455 kHz is tuned to 1000 kHz. Find image frequency, and second one it is the local oscillator frequency. Okay, the tuned frequency it is the 1000 kHz, means its RF frequency and IF frequency which is given as a 455 kHz. Okay, so formula for the calculation of image frequency, it is the image frequency is equal to RF frequency plus minus 2 into IF frequency. The RF frequency it is the 1000 kHz and IF frequency it is the 455 kHz. So it is the 1000 kHz, so it is the 1000 into 10 raised to 3 plus minus 2 into IF, it is the 455 kHz. So it is the 455 into 10 raised to 3. So we are getting as a 1910 kHz. It is the sum frequency, and difference frequency it is the 90 kHz. Okay, so this 90 kHz frequency which is the, it is the not possible. So we are considering as a image frequency as 1910 kHz. So this is the image frequency. Next one, it is the local oscillator frequency. This local oscillator frequency which is calculated as RF frequency minus intermediate frequency. RF frequency minus intermediate frequency. So RF frequency it is the 1000 kHz. Okay, RF frequency it is the 1000 kHz and IF frequency it is the 455 kHz. RF frequency it is the 1000 kHz and IF frequency it is the 455 kHz. So we are getting as a 45 kHz. It is the 545 kHz. So this is the local oscillator frequency. This problem is asked in a MSBT exam. Okay. So here we have completed the third chapter. Also we have completed the principle of electronic communication syllabus. Okay. So lastly we will see the third chapter MSBT question. Okay. So first question it is the draw the block diagram of AM super heterodyne receiver and state the function of each block. You have to draw the block diagram of AM super heterodyne receiver and explain the function of each block. Next one it is the draw neat block diagram of FM receiver and explain function of each block. Here they asked the FM receiver, that is the FM super heterodyne receiver. You have to draw the block diagram of FM super heterodyne receiver and explain the function of each block. Next one, list the different methods of FM demodulation. List the different methods of FM demodulation. You have to list only the different methods of FM demodulation. So different methods of demodulations are simple slope detector, balanced slope detector, phase discriminator, ratio detector and PLL. Okay. Next one, sketch the graph of pre-emphasis and de-emphasis. You have to draw only graph of pre-emphasis and de-emphasis. Next one, explain necessity of de-emphasis circuit used with FM receiver. You have to explain the de-emphasis circuit used with FM receiver, means you have to explain the de-emphasis. Next one, explain the function of pre-emphasis. You have to explain the pre-emphasis. Next one, explain de-emphasis with neat diagram. Again same question, you have to explain de-emphasis with neat diagram. Draw pre-emphasis and de-emphasis circuit used for FM transmission and reception. So you have to explain pre-emphasis and de-emphasis with graph. Next one problem which is asked, we have already discussed it. Next one, it is the explain simple AGC and delayed AGC with the help of neat graph. Okay, so you have to explain simple AGC and delayed AGC. You have to draw the AGC characteristics and explain the simple AGC and delayed AGC. Next one, it is the draw the labeled circuit diagram for the ratio detector. Okay, you have to draw only diagram of ratio detector. Okay, write the intermediate frequency of FM radio receiver and medium band AM. So intermediate frequency of FM, it is the 10.7 megahertz, and medium band AM, it is the 455 kilohertz. So this is the intermediate frequency. Next one, it is the draw and label PLL based FM detector. So you have to draw PLL based FM detector. You have to explain. You have to draw PLL and only you have to show the capacitor for the FM detector. And you have to explain the FM detector. Only draw they asked, so you have to draw only the PLL based FM detector. Next one, it is the draw the practical diode detector circuit and its input and output waveform. Here again they asked only draw the practical diode detector circuit. So you have to draw only the practical diode detector circuit. Compare simple AGC and delayed AGC. Okay, you have to compare simple AGC and delayed AGC. Next one, it is the explain simple AGC and delayed AGC with the help of neat graph. So you have to explain simple AGC and delayed AGC with the help of neat graph. Here we have completed the third chapter. Also we have completed the syllabus of principles of electronics communication. Okay, so if you have any doubts, then ask me. Okay, and here we will stop the lecture. Thank you.